Hi there, this is Chet Arnold from the University of Connecticut Center for Land Use Education Research, and you're staring at a rather messy desktop, which is my desktop, and that's because we're going to do kind of a live recording here with no safety net, trying to show you around a very cool new web tool called WikiWatersheds, which is going to enable you to choose an area and then analyze the stormwater runoff from that area in terms of the quantity and the quality of that runoff. So let's get started. I'm going to fire up my browser, and the first thing I'm going to do is to go full screen so we don't have to deal with all this clutter. And then let's search for Wiki, W-I-K-I, Watershed. And we'll go right there. It pops right up. Now, the Stroud Water Research Center are the creators of this tool, and they've created other tools, and they've really done some fantastic work. But we're going to look at the one on the upper left-hand corner, this Model My Watershed. So we're going to launch the app. And I believe, sorry about that sound, that it's going to, yes, ask me for a login. So this is where you would create a login username and password, which I highly recommend you do because that way you can save your work. So I'm going to log in. You're not going to know my password, but it's related to my pets. I'll just say that, just like 90% of the rest of the Americans. Alright, so this is where it goes. Now this is actually, it's sensed where I am, which is in Haddam, Connecticut, our offices, and so the interactive map on the right has zoomed in on that. So let's just press the Get Started button because we can't wait. So the first thing to do is you want to select the area that you're going to analyze. Before we get to some of these choices over here, let's search for an area. Well, okay. So let's say that we're from the great Connecticut town of New Britain. But now it's going to take me to New Britain, and if you look at this layers box down here, click the little layers icon that most of us are familiar with, you can see that it's a street map, but you can also choose a terrain map. That doesn't look too much different to me. Or you can choose a satellite image. So there's New Britain, and then of course we can back out, and we're all familiar with working with these types of maps, of Google Maps. So to look at the area that you want to analyze, you can select a boundary from some of their units here, congressional districts, school districts, watersheds, but the watersheds only get down to the HUC 12 level, which are still fairly large depending on what you want to do. If you want to look at your high school, your school campus, that's going to be too large. So the best thing would be to draw an area, and you can either do a free draw or a square kilometer. So what I'm going to do now is narrow my search down to say I want to look at New Britain High School. I can't type. There. And it found it. So it's going to take me there. Beautiful. That's a very large building. So there's New Britain High School. Now, we can draw an area around it. We can say we're going to do a square kilometer in which you would pick a point, say right in the middle of the school, and it'll draw a kilometer block. I prefer probably free draw, so that you get a more approximation of just the campus. So with free draw, you can click that, and then you can kind of delineate the campus points. And again, I'm not going to be doing this accurately, but we're not trying to keep you for 6 or 7 hours here. We want to get through this in a time. So there we go, and then double click at the end, and I've created the area that I want to analyze, and you can see that it's already analyzing in the left-hand column. Now the analysis it's doing now is it's going to national data layers and looking for things. And I should mention, because I haven't mentioned before, that there's a level of specificity that it has for Delaware, which the Stroud Center was funded to do a very detailed version of this model for Delaware, and there's only a little less functionality for those of us in other areas. But right now it's looking at the National Land Cover Database and showing the distribution, and you can see because of the area I picked was the campus, it's mostly this very developed, medium, and high intensity. And so you have the chart on the top and the actual data on the bottom. The other one of these ones on the top that actually work for the whole country is the soils. So this is going to a national database of soils from USDA and looking at the different kinds of soils. And again, information at the top and then the actual numbers of it on the bottom. So that's just kind of a general look at the area. Now what we want to do is down here on the lower right of this left-hand column is click Select a Model. And we want to select the site storm model, so looking at stormwater. So right now it's already churning through the results, and what it's doing is using a number of national models by EPA and USGS and others, and kind of fusing them together to look at a 24-hour hypothetical storm event and what happens to the water that falls on this particular selected area during that event. And you can see from the bar graph it's divided into just three very simple components. The light orange, which would be what infiltrates into the soil, the dark orange, which is what runs off, and then the green, which is what's returned to the atmosphere in evapotranspiration. And again, a nice graphic here, kind of an interactive graphic, and then the actual numbers if you're interested in the numbers on the bottom. And then I just saw this new feature they have is download the data, and I have not tried that, but I assume you can download it in a number of formats. So that's the current situation, but if you want to look at other particular scenarios, that's what makes this tool so useful and so interesting. And so you can alter various things. Now up here in the upper right, you can actually alter the size of the storm, but even more interesting is you can click this very modest button. I'm not sure why they made it so modest, but add changes to this area. And what you're doing now is creating a new scenario. So now it's this untitled project. I should have named it. I'm going to say New Britain High School. And then this new scenario, I want to name it too. So I'm going to go to New Scenario, and I'm going to name it LID Makeover. Now what do I mean by that? So LID stands for Low Impact Development, which are a number of practices to help get that water back into the soil. And this scenario, we're going to add LID elements to the New Britain High School campus. So conservation practice, there's two ways you can change and create your scenario. One is to change the actual land cover. So if we wanted to change this parking lot, for instance, into a forested area, we could go ahead and do that. And that's really interesting also for non-developed areas when you start to put in developed areas or agricultural areas. For this demonstration, we're going to use, however, this other button of tools, which are conservation practices. And these are basically low-impact development practices that you can do. Some of them are ag-related and housing-related, but these are all kind of site-related. Rain gardens, vegetated basins, so similar to rain gardens, porous paving, and green roofs. So let's just say that we're going to build a big, huge green roof on this part of the building. And then what you will notice, if you can notice, and we're going to show you how to really get a handle on this later, but is that the chart and the numbers will change depending on what you've just done. So there's the green roof, and then we love porous paving, so we're going to take this whole area of parking and turn it into porous paving. And we're also going to take this area of parking, let's do it again, and turn it into porous paving. Now, we could do a lot more, but we're just trying to show you, for instance, what happens. Okay, so now we have our scenario where we've added some pretty serious LID components. And so what does that mean? Well, to check that out, you go to this other little button on the upper left-hand corner, which is Compare. And it's going to take you to a very interesting page. Now, on this page, you have several things. You have current conditions, which is what you originally chose and showing you based on the land cover that it sees, what the runoff quality and quantity is like. We're looking at quantity now. I'll show you quality in a minute. And then here's our LID makeover, and also the creators of the model have added this 100% forest cover, so kind of a completely non-developed reference point. And what we're looking at here are familiar and by now bar graphs of the three components of the runoff. Here's a forested, where you can see the largest component by far is infiltration. Current conditions, which are quite developed, where the largest component is in runoff and basically very little or no evapotranspiration. And if you roll over the sections, you can get the numbers. And then our LID makeover, and you see that we've regained a little bit of infiltration and reduced the runoff by use of our LID components, and they are listed down here. You can also change the storm at this stage and see how it changes the numbers. So that's runoff or water quantity. Now if you pick this little pull down menu, you can also choose water quality, and get the estimates that we looked at before, similar bar graph, but this time showing the loadings of these three pollutants in the runoff, so suspended solids, nitrogen, and phosphorus. This one can be a little tricky because the scales can change. So in other words, these two graphs look very similar, but if you look at the scale, you can see that on the forested cover, it goes from 0 to 11, where the current conditions, the scale of the bar graph goes from 0 to 97. So if we look at this kind of teal color suspended solids, just to go through one example, 10 kilograms per hectare in the forest cover, 95 kilograms per hectare in the current conditions, and then using the LID practices, we're able to knock that down to about 60 kilograms per hectare. So quite an impact, and again, the conservation practices are listed down here. So that's pretty much it. We hope that you and your students will be able to use this tool to better understand runoff, both the quantity and the quality, and what happens when the landscape changes or when you put in LID practices, and play with it and have a lot of fun with it. Thanks.